All right. Good morning, good afternoon, good evening, everybody, wherever you are in the world. I hope you're having a fantastic day and welcome to the Polyhedra show. So, the episode of this show is titled Encrypted Futures, and this is a partnership spotlight. We are joined today by Christian, the CEO and co-founder from Mind Network. This is a partnership that's both exciting and really just makes sense. Polyhedra has been laser focused on trustless infrastructure for AI and interoperability, and Mind is building encrypted AI frameworks with fully homomorphic encryption, zero trust data layers, and a vision for how AI, Web3, and privacy collide. So, in a world where AI agents are about to start making real decisions, the stakes are high, and so is the demand for bulletproof encryption and zero knowledge systems. That is why this partnership is such a natural fit. We've got two teams aligned on privacy, security, and moving past outdated surveillance-based architecture. So once again, we've got Eric Vreeland leading the fireside today. We're going to unpack what Mind is building, where it fits in the decentralized landscape, and how it ties into Polyhedra's own roadmap. As always, we've got the AMA coming at the end with some sharp questions straight from you guys, our community. So let's dive right in. Thank you so much for joining us today, Eric and Christian.
Thanks a lot, Anthony. And Christian, welcome to the Polyhedra show. It's great to have you.
Thanks, guys. Thank you, Anthony. Really good to see you guys. Happy to be here, man.
Yeah, I know we've been talking to you guys for a while, so it's great to see this kind of coming to fruition. For the Polyhedrans on the show that may not be familiar with you or Mind Network, can you give us a quick intro on yourself and how you came to start Mind Network and what is Mind Network?
Sure, of course, yeah. So Christian, CEO of My Network. I was working in medical technology actually in my previous life. I'm old enough to have had a previous career before crypto. And in medical technology, I was helping, I was working with engineers and startups that were developing AI back before it was cool, before the chat GPT moment. And in order to get the AI better for surgical navigation devices and surgical devices themselves, they needed our teams needed more data. And so, as leading up the BD and the marketing side of these startups, I kept running into the same problem. Like, okay, so our AI is like 90% successful or accurate, but you can't go to market with 90% accuracy. You need like 99.8 to even be viable to go to market. And we couldn't get that extra 8% unless we had more data. I'm like, well, what's that problem? How do we get more data? And you start learning that, like, there's, first of all, there's regulatory problems that prohibit the sharing of data for good reason. But there's also really no incentive scheme available that would incentivize big data holders like insurance providers, big medical device manufacturers that have a lot of data to share it with smaller entities that are maybe more bootstrappy and can like innovate quicker. There's no incentive structure to do this. And so um, I started ideating, well, this was back maybe 2018. I'm like, well, blockchain seems like I might be able to kind of address this. And so that was the beginning of the end. You know, once I got into trying to bring a blockchain backend to a traditional company, which didn't work, by the way, at all. But it did at least show me that there was promise. I mean, in my thesis was like, look, if this problem's going to get solved, and it's not just a health data medical problem, that's where it's acute, but it's not just there. We need to find a way to have access to data in a way that protects IP, user rights, sovereignty, individual privacy, all these things. I saw a much more viable path happening in the technologies that were arising from crypto than I did in the standard SaaS Web 2 traditional world. So I jumped in, and my first project in crypto was an IoT, was a DeepIn project, one of the foundational DeepIn projects. And so there I got to kind of go into some privacy preserving technologies. We had our CSO on that team was brilliant. He was an all-star from Waterloo, was working on ZKs back when people were like trying to figure out like ZK Stark or ZK Snark. What do these mean? And then I just went down this rabbit hole of like privacy preserving technology. And to me, it's addressing one of the biggest problems in crypto. The elephant in the room is privacy. Obviously, Polyhedra kind of shares our vision on this. It's like if Web 2 became Web 3 tomorrow, Lucy, we have some talking to do. Like there's a major privacy issue. You don't want all of your data. You don't want your subscript from a user perspective. I don't want all my subscriptions settled on blockchains and publicly available, tied to a pseudonymous wallet, which a number of services can now figure out, like Arkham and Kaido. And but also for institutions, you don't want them we don't want that being public either, like banks paying each other or governments. You don't want bad actors to front run that, extract value from that. You don't want vendors and suppliers to have a completely publicly settled payment system where every buyer of a product can see what all the other competitors are paying. That's a nightmare. So we kind of believe in that. This is the elephant in the room to solve. And so yeah, my network started developing FHE a little over 2 years ago. I was connected with some really bright people, much brighter than I am. I don't have a PhD in AI. I'm business marketing, investor side, but my co-founders are PhDs in AI, cryptography, great careers before crypto in banking and in Web 2. And so FHE it was really exciting. The holy grail of cryptography. It's been called that for 40 years. It was theoretical for like 3 decades. It wasn't until the 00s that FHE finally had an application, which was in protecting the sequencing of the data and sequencing the human genome. Human genome, very sensitive data. And FHE was used at the time to protect that data while they were sequencing it. And so since then, it's been getting a little bit faster. It's heavy computation, but the chips are scaling, the algorithms are scaling. My network has done a lot to optimize FHE performance in-house. And so now we use this holy grail of cryptography to protect a whole bunch of data. And for anyone listening, when I say the holy grail of cryptography, FHE is the only scheme we know of that can process encrypted data without decrypting it. So for most other methods, if you want to process the data, you have to decrypt it, process it, and then you can encrypt the output, but you don't keep it encrypted during the processing part. And so this is kind of a key solution, I think, in building what will be the future of the web, the next iteration of the web. So I'll pause.
Absolutely. And you touched on a few points. One, we get told or people discuss all the time, why have we kind of hit this roadblock when it comes to adoption? Why hasn't blockchain surpassed credit cards when it comes to payments? Or why haven't institutions and in finance and otherwise started to utilize blockchain for, like you said, their supply chain or interacting and transacting with business partners? And my response is often like, would you want all of your credit card statements, on publicly visible for everyone to see? And most of the time the answer is like, absolutely not.
Right.
And so I think, this is a great step towards that end goal, because I think we do all see the benefits, but there is this elephant in the room, and now it's starting to be, I guess, addressed. Now, I guess my question for you is, like you said, this has been theoretical for 40 years now. I remember when I was first getting into blockchain and into cryptography, like a lot of my friends that are way smarter than me have, we're learning about ZK and then asking me about FHE and saying, at the time it was like, yeah, I don't know, that seems very aspirational, but a long ways off. And to be honest, if you would have asked me like 5 years ago, if we were ready for when we were going to see something in production or usable, I probably wouldn't have guessed. I probably would have guessed way further in the future. And similarly with ZK, we've seen rapid progress over the past few years. But what has it been that, and I'm guessing it's probably a combination of these, but what is kind of the tipping point that really made this something that is now feasible and is now like ready for production use? Is it progress being made on the algorithm front, progress being made on the hardware front? Tell me about why is now the time where FHE is ready for its, spotlight?
Yeah. So I think the answer is both. So a good analogy is like what DeepSeek just showed the world a few months ago is that we don't have to be so reliant on the hardware acceleration in order to make this model performant, right? So they pushed out this AI model that was as performant as ChatGPT with less GPUs because they optimized the software, not the hardware. So my network has done a lot of work on that. We've optimized the software to make it faster and to make it work better to help the bootstrapping process. There's also companies out there like Zama the largest cryptographic FHE resource provider in the world. They've raised like around $100 million. They're based out of France. So any FHE project in the space is most likely using one of their libraries or one of their tools. They've done a lot as well to abstract away this the FHE part for developers. So developers don't have to know how to code with FHE. You can use their tools to code the way you normally would, and still have the benefits of it. So companies like that are making it easier for developers to work with it. And then, yeah, on the hardware side, like companies like Cornami and Optalysis, the chip manufacturers, they're scaling quickly. And Optalysis has this, one of their innovations is that they're going to allow their chip to perform computation in coherent light, which sounds like Star Trek. I mean, but essentially it's like doing math in a laser light, so that the speed with which you can perform computations is exponential. So we're looking at, between that development and others from Cornami, like, a 1000x acceleration over the next 3-ish years, I think is what they're saying. And by that point, that means at that point, what does that actually mean? Like, you could have a fully encrypted LLM about 3 years from now, probably. Right now, if you wanted to fully encrypt the prompt and then the computation with ChatGPT, it might take 20 minutes to get the inference, to get a response from that. That's obviously not going to work, but within a few years, we'll have the ability to do that. So it's just scaling fast, and it's scaling, Moore's law and all the laws. It's like it looks like it's going faster than we even thought. So yeah, and we started out honestly just with really simple computation. Like, our hack was like, look, let's just keep this to like, addition, subtraction, like basic computation, and there's plenty of data you can encrypt that's just simple computation. You can do that. Or like at the validator level, for example, the validating nodes for any L1 or L2, it's like let the miners do their computation and then just use FHE for the output. And then at least that output is verifiable on chain, and you can still create a shared private state for all the validators to come to consensus in. At least that's a security upgrade for every L1 or L2 that, isn't Ethereum, that's proof of stake, that isn't Ethereum. Ethereum is sufficiently decentralized that most L1s and L2s are trying to bootstrap decentralization, and they have to do it carefully, because every added node is it's a vulnerability if they're going to attack the network or become whatever. So you've got time bombing and slashing, and those can work, but this just kind of makes everything a little bit better. And that's actually really simple computation. So we've been like cherry picking types of data where FHE is performant now and doesn't slow down tech stacks and processes.
Can you dig into or expand upon the work that you guys are doing on consensus? So I guess, where does this encryption come in, and exactly like how does it make it more secure for let's say a new network that's kind of bootstrapping?
Yeah, it's a really good question. I mean, I think I would zoom out first of all and say, like, conceptually, like you could say that the demarcation line from crypto Web3 to Web2 is a departure from single point of failure, single decision making entities to consensus. And so it's not there's multiple layers of consensus. I'm speaking to like a general audience, general user, obviously, not you guys right now, but consensus has to be achieved at the validator level, obviously, to close blocks and verify transactions at the block level. But then you also have DAOs. DAOs all vote on agendas and initiatives, right? That kind of govern the way an organization is going to go. So in that situation, you have a consensus has to be achieved. In AI networks, they function a lot like the validator level of any L1 or L2, where like you have a miner, like the BitTensor model, for example, is you have a miner who hosts the model, and then you have the validator that's validating the model, ranking it, with the credentials that are put forth for that particular system. And so that's these validators have to come to consensus over, like, is that model performing well? So there's multiple ways where this is just, the theme of Web3 is like consensus has to be achieved for multiple processes to happen. That's how we have such a secure, decentralized web. So really, for a lot of those, we can create a shared private state. And so, in the AI example, I gave you the validator example for L1s and L2s in POS systems, but in the AI example, the bad behavior that was happening all the time is that a miner is hosting a model and then jumping on the validator side to validate their own model. Conflict of interest, obviously. So if you can use FHE to encrypt that data, they can't do that. The second thing was happening was the lazy node issue, which is an issue in AI, but also in smaller L1s and L2s when they're just getting started, which is that every validator is publishing their answers publicly before there's a gap between when you publish an answer and when like the winner is selected, right? So in that process, if it's public, you have some lazy nodes just copying. So they can look at like what validator is staking the most tokens, for example, or seems to have access to the most compute. This probably means that this entity running that node has like, a lot of resources, financial resources. So you copy them, get the right answer, show the rewards. So that was happening a lot in AI networks. So again, create a shared private state, and you make sure that the consensus that's achieved is everyone doing their own work independently. There's no copying, so you just make it more secure. And if you can't see the answers, you reduce the ability for bad actors to create vulnerabilities in the network. And then, another example, like with DAOs, you have some voters that are staking a lot of tokens. They might influence the vote of other individuals. And so you don't want that to happen. You want everyone to purely vote the way that they want. But the big one really that we've been working on recently is agents. So in the agentic world, agents, obviously, to be helpful, have to know a heck of a lot about you. And they're going to be taking that data. They're going to be going out in the web, talking to other agents, other swarms of agents. And right now, in the current infrastructure, we don't even know. We have no way of knowing what's the data about you that an agent is carrying, that it's sharing with other agents that might be making calls about that data without even necessarily using it. In some cases, they might be abstracting data from your agents that they don't even necessarily use, but they're going to get it in plain text, and now they're carrying it. And so who knows who else is going to get it? So I kind of think of it like this, like the web from 95 to 2025 has been, data sharing has just gone up like this. In order for us to have the products and services that we use, we've had to increase our data sharing, and all these apps extract more data to be more insightful. All of these LLMs were built on scraping data off the public web. That sharing now in the agentic world that's coming is just going to go up and to the right even faster. And you're going to start to see a move toward private data. So really when agents are really, really effective, they're going to be accessing private data. This is stuff like health data, like the vast majority of data that's available is private data, stuff that's protected by regulations. It's health data, medical data, like really personal stuff. The public stuff is easy. That's actually less of what's on the web. So we have to find a way to access the private data if you want to make agents more useful. But at the same time, that is a security nightmare. So we need this basket of technologies now called, I think by Messari, decentralized confidential compute, which comprises FHE, ZK, MPC, multi-party computation, and TEEs. And so I think this, for Polyhedra, for my network, for Zama and Phoenix and all the rest of them that are in this, it's a really exciting time to be in this space, because I think we're going to be called upon increasingly in the agentic world to start helping make private data accessible for AI, but also protecting it and being compliant with current regulations in every jurisdiction around the world.
Yeah, I was going to get here eventually, but you're kind of guiding the conversation. So let's talk about agents some more.
Yeah.
So in this world, like that, where we have agents that are highly specialized and operate in these kind of swarms, where we're envisioning them, each kind of being very good at a specialized task. And if they're asked to go, you maybe have a manager agent that's kind of orchestrating all of these other agents. And like you said, they need to have access to more obscure and potentially private data in order to do a good job, especially, if they're working for individuals or corporations that all have very specialized needs. Do these agents, and maybe this is, down in the future, but do these agents all need to kind of be FHE enabled for this system to work? Or is it possible for like an FHE enabled agent to interact with a non-FHE enabled agent and still take advantage of that private data? Does that question make sense?
Yeah, I think it does. So this is a more technical question, but yes, you can have like non-FHE enabled agents interact with FHE enabled agents. And I suppose we'll get into the ZK aspect in a moment, or do you want to jump into that now?
Yeah. Well, if it's relevant now, let's do it.
Well, yeah, only because so let me explain specifically what we built. So we built basically an orchestration network. You can think of it as like model context protocol, right? Which basically just kind of created this like basket of API calls already made. You've got like a prefixed set of API calls to make the LLM more performant. We're kind of like an orchestration layer similar to that. So agents that are launched on virtuals or swarms or ELIZA, whatever, they can come register on our orchestration network, which means number one, they can have their task be protected with FHE. because if you have a swarm that's being run by a DAO and that swarm's purpose is to like make a lot of money like solely on Bitcoin, and they're doing a good job, they're doing a really good job, you might have an adversarial swarm come and try to look at the task and then, you know, trade against you in certain markets or whatever. So like, it's good if you can have the task be protected with FHE. And then the memory that the agents each individually have can be protected with FHE. So that's what we've built specifically. So those agents that register on the network still can interact with agents that are not registered on our network, of course. But at least their agents register with us have their memory encrypted with FHE, and their task can be protected with FHE. But when we're talking about how do we trust the agents themselves, this is where ZK comes in, because ZK makes agents verifiable without needing to trust them. So you can like make the actual agent kind of protected with ZK. And I think this is the difference between ZK and FHE, is like when you don't need to have this like one-to-many kind of computation where it's like if I run computation on some of your data and I know that thousands of other entities are going to want access to that, it's really handy if the computation I ran can live on chain in an encrypted state but be verified by thousands of other individuals that don't want to run the cost of compute, but actually just want to make sure that the work was correct. They can do that on chain. That's harder to do with ZKs, but where ZKs are better is scalability, obviously. And if you don't have to constantly check the work because it's something that's trustable, that's a better, this can be, ZK can serve the circumstance much better. So zero knowledge proofs are kind of how we make AI agents verifiable without needing to trust them. And then using FHE right now, I think is important just to have the task and the memory encrypted. So it's a 1-2 punch. It doesn't mean that every single agent has to have these, you know, non-encrypted agents can work with encrypted agents. This just seems like a much better way to go. You know, obviously, I think we'll gain a lot of market share over time.
And if you know, if you're a user of these agents, let's say you're just like a consumer, what would be your, you know, explanation to an individual as to, you know, why it should be important for them to make sure that their agents are verifiable? Like what could happen? What is like a doomsday scenario, or what is something that could go wrong in the case where they're unable to verify an agent?
So I guess it wouldn't be so much, the question isn't whether they're verifiable or not, because it could be verifiable in plain text. You could just have it's more like if yeah, I think it's more a question of like, look, if we don't encrypt any of this data, it's a security nightmare waiting to happen. I mean, you're going to be sharing just way too much information about yourself, your business IP, your health information, the way you talk, the way you type. There's just so much now that can be grabbed. So if you want AI to be performant for you, these agents to work for you, the question is, you have to share a lot of data. So do you want to do that and have it be completely accessible to almost everybody? Or do you at least want it to be protected? And then if it's going to be protected with FHE and not visible in its plain text form by anybody, any agent anywhere, but still the insights can be extracted from it without actually seeing the raw data, that matches the web that we're building into, which is where we need way more data for agents to really be helpful to us and truly become administrative assistants or copywriting assistants or coding assistants. You need to share that data, but if you do it without any kind of encryption, you know, that's a security nightmare. Bad actors can get it, nation states can get it, and who, you know, yeah. So I think that's more the question of like, if we want performant agents, there has to be more data sharing. Do you want that to be public or private?
Absolutely. And I think it's clear to see how this is relevant on the blockchain, but also how this is relevant to Web 2 and kind of the internet as you know, we used to know it. And I know you guys have done a lot of work and spoken about kind of this HTTPZ, which, you know, is the next evolution of HTTPS. Can you talk a little bit more about that and kind of what your vision is for not just this on the blockchain, but kind of the next evolution of Web 2 and how this is relevant to what you guys are building?
Yeah, yeah. Full disclaimer: Zama put this idea forward. We just thought it was brilliant. It was
Yeah.
Ran Hindi, the CEO of Zama. So we subscribe to it. We talk about it, and we're building into it. So the idea was that, like, with HTTP, for those that are like under the age of 30 and don't recall this web, but like in the 90s, we had HTTP, which was just basically like the servers and websites were talking to each other publicly to call data. So it was just a lot of information that was too public, and they allowed for a lot of the hacking of data. So they made HTTPS, which secured basically the communication between servers and websites and the calling of websites and everything like that. So that allowed the web to be a little bit more secure. So there wasn't data sharing from website to website and landing on individual servers without, without there being some consent. In HTTPZ, what we imagine is basically a step up from HTTPS, where the Z stands for zero trust. And as you guys know, zero trust is this it's a term in developer communities where you talk about any data that comes into an environment needs to be treated as untrustworthy. So we're gonna assume any new data is basically contaminated, which means that we have to verify it, we have to encrypt it. We're not going to trust anything. It's a trustless place, zero trust. So it's a big idea. I mean, usually like zero trust environments are in like closed environments, right? Like this is like something an IT guy can do. But to say that you want to apply a zero trust environment to the entire web, that's like a moonshot. That's a really big idea that would take a really long time. But if you think about, again, the agentic world that Satya Nadella has put forth just a few months ago at his keynote at the Microsoft meeting, and what Eric Schmidt's talking about, and Bill Gates and some of these AI guys, I mean, it's like in 5 years, it's going to be pretty ubiquitous. Like AI is going to be everywhere in the form of agents or LLMs, and then who knows what form, um, artificial general intelligence takes. But yeah, in that world, you really do want a fully encrypted web. So that's what HTTP represents, basically an entire web that is just secured with various forms of encryption, but FHE being the leader, and then MPC in certain scenarios as a sort of ancillary encryption or ancillary method, CK as well, and in some cases, trusted execution environments. So yeah, it's a big idea. It'll take many years to achieve, but we're focused on just a kind of a strict set of data that we're using right now to create HTTP's environment, and there's other builders doing same. So we're just tipping away at it.
Awesome. And I guess to dig into one piece you talked about, kind of maybe 3 years from now, where we're going to have fully encrypted inferences, which would take like 20 minutes, I think you said now. We haven't really talked about the training process at all. Are you guys doing work on model training, and what does that look like, and why is it important to incorporate encryption and FHE into the model training process?
We've worked with Allura on the inference. The training is a little bit trickier. There's just so much more data. Zama does have a concrete ML SDK. So we've leveraged that at times with some of our partners. We've like BD together. I think right now that's probably one of the best ways. We can encrypt some of the training data, but this is an area where the performance starts to lag. So Zama's offered a really great tool here called the Concrete ML SDK. Definitely recommend people go check that out. And we've gone to market with them. We have an AI initiative with Zama so for AI networks, they can help like in that AI situation, that like on a BitTensor subnet, for example, you can use their Concrete ML SDK for training data. And then on the validator side, you can use my network for creating a shared private state for the validators to come to consensus in. So this is kind of like a hybrid FHE LLM solution. It's the closest that we have in the market at the moment. And so we've built that with them.
Got it. Amazing. And then I guess going back to ZK, when you were out there evaluating, different zero knowledge technologies, like what were the criteria that you guys were looking at, and what was important to you when you're looking to kind of add this verifiability on top of the encryption technology that you guys offer?
So we're looking for essentially a trusted partner with usership that's applying ZKs in the right area. I think that Polyhedra, for example, is kind of focused on this interoperability piece, which is really, really clutch. We've been lucky enough to hear some of the conversations that come from TradFi and from big Web2 players. We've been like in a couple of those meetings, and they really are just like they do not subscribe to the complexity with which everyday users like us are subjected to in crypto. Like we have to abstract away a lot of this, and so we are looking for users that see that and that also want to focus the technology, the privacy preserving technology, in the right place. So bridging is huge. You definitely, this has got to happen. We need to have a few trusted bridges in the space that will allow Web2 and TradFi to come in a trusted way. That just has to happen. I don't think there's going to be the need for dozens. I think that there's going to be probably a small group of trusted, and I think that those companies are going to be brought into the fold by some of those TradFi institutions. There's going to have to be a close relationship, like at the working level. I mean, as much as that's just going to have to be the way it happens, because it's a big leap of faith for TradFi to start using a lot of these technologies en masse to move billions or hundreds of billions of dollars, right? So there's no way around that. So we look for institutions, we look for projects that at least have that capability to handle those relationships and that have the right idea, the right application of the tech, and that have the user share. So that's what we were looking for, I think.
Amazing. And so you've mentioned a little bit, your background in healthcare. We've talked about finance. Are there any other use cases where you see kind of leading the way when it comes to adopting this technology or driving innovation?
Yeah, I think AI for now. We talked about the agentic world quite a bit. I actually think in what I'm seeing in Silicon Valley since January is that capital is flowing into healthcare again, which over my career I've noticed every several years, like tech bros in Silicon Valley are like, hey, there's a crap ton of efficiencies need to be made in healthcare. Let's go back into that again. And they come in kind of with their chests out and a bunch of capital, and they're going to fix everything. And then like very few of them ever really make any real money, and they kind of go back to doing whatever, some other sector. But right now there's like this resurgence again into how there's been a lot of capital deployed by the big VC firms, Sequoia and et cetera, SoftBank, toward health and AI. So I could see that trickling into crypto at some point later this year. Health was cool for a minute. Like we had Step In and Health Block, some smaller projects that started in the last bull cycle that made some traction. Like the vision was easy. The thing about like deep in health is it's super easy to understand. Like the model was there. Like basically get paid for sharing some easy HIPAA, outside HIPAA, outside GDPR health data, like steps, or
Yeah.
heart rate, stuff like that. So the model's super easy. It's just a matter of protecting the data. But I don't know. I mean, I'm keeping my eye out for health to kind of make a comeback in, D-health or the health subsector of DeepIn to make a rise later this year, because there's really obvious advantages to using FHE there.
Very cool. And for the developers that are listening right now and potentially building something with AI agents or something where there's interacting with sensitive data and that these things are top of mind, is this something that they need to incorporate from day one, or would you recommend building out your solution, getting a
No.
little bit of product market fit, and then retrofitting and figuring this piece out later?
Yeah, so we have a few different tools. You don't have to build from day one. So we have our agent, like we have our agentic hub. We have like a hub architecture on the one hand that's like similar, not the same as BitTensor. So a number of A1 projects, AI projects have basically built a hub with us, and they're using FHE to encrypt certain services. And so there's something to do there. But we also have SDKs. So really plug and play. I mean, we launched DeepSeek integrated our SDK. So you can build with DeepSeek and protect your data with FHE. Eliza integrated us. There's a few different ways to work with us. It depends on what you're building, but we've got some easy plug and play tools as well.
Amazing. And I guess before I call Anthony back up to give us some of the community questions, just like, what are you looking forward to this year? What does the end of the year look like for you guys to be like, yeah, we nailed it, or we're kicking ass and excited? What does success look for you guys this year?
That's a great question. I want to ask Polyhedra the same thing, actually. See if we're on the same page. So I'll go first. You go next. I definitely want to see. I want to productize I want our existing products for DeFi to scale. So I mean, to me, just for simplicity's sake, DeFi to me is like it's all this. It's like RWA, it's payments, it's settlements, it's bridging. Like to me, that's all DeFi. I know that we've kind of segmented those things away from each other, but we have solutions into all of that. I want to see scaling in that area. And then we've been productizing in AI for a long time. So I want to see that continue. I'd love to see, hundreds of millions of agents basically registered on our orchestration network with my network. That would be a big win. And then if we're being used in I think what's going to be a huge DeFi wave that's coming once we get the stablecoin policy figured out in the States, and once the States potentially even this year also has a broader framework for crypto, that might happen as well. I think when that happens, I think DeFi is actually going to be the biggest thing to move because there's been so much capital waiting for years for this stuff to get settled, and it's going to move finally. So I'd love for my network's products to be used and facilitate that capital going from TradFi, Web2, big banks into public chains. We would love to be a part of that.
Very cool. And I owe you an answer. So for us, I mean,
Yeah.
we really have kind of put the majority of our resources towards building out zkML and verifiable AI. On the LLM side, we can do a verifiable inference of 6 billion parameter model in a couple of hours now. But like you said, with Moore's law or exponential Moore's law, with the hardware acceleration, with the GPU acceleration, which with all of the improvements that we're seeing on some of our own internal optimizations, like we want to get that down from a couple hours to sub minute, or even a matter of a few seconds. And I think that's really when you can get to this real time verifiable inference, and you can people don't have to wait, and it doesn't have to be somewhat of like an optimistic verifiability. That's going to be really powerful. And then on the agent side, we're working obviously with you guys and some other institutions on the verifiable agent piece. And we have a couple products that we're looking to kind of bring to market to help with this future that we're both aligned in, where we want users to be able to have confidence that the agents that they're interacting with are the ones that are they expect to, and that they're executing correctly and following the constraints that they've been given, etc.
That's awesome, man. Yeah, I wonder if people understand how big an idea the verifiable inference is that you guys are working on. That's just such a big idea in my mind.
Yeah. And I think we'll have some really, really exciting stuff to share on that front over the next couple months. So maybe when we do, and I know you guys are always, you guys are moving very quickly as well. So we probably need to have you on, once a quarter just to give it an update, because there's so much overlap in kind of the stuff that we're working on. So it's great to have you on as a partner. I see Anthony waiting in the wings. Let's see what the community has for us today.
I'm back. That was an awesome fireside and chat, gentlemen. Obviously I get to chat with you a lot, Eric, but Christian, we've had some brief chats, but really great to hear your insights and get your history and what you've been up to. Before I dive into some of these community questions, and there has been a lot. I think I was about 700, 800 for this one. Again, I did pick out like 20. You guys rolled through most of them. So I'll try and pick some pertinent ones. But just quickly, Christian, in the background there, does that sign say Tower of Data?
It does. Yeah. That's my Twitter handle. And my handle in several places. Cool. Yeah.
Nice.
And then this is
nice one to lock in.
It's hard to see. It's hard. I got to redo my background, but it's hard to see that picture. But that picture is an ocean with a bunch of zeros and ones in it. So it's an ocean of data. But I need to bring
nice.
I haven't figured out how to bring it closer so people can see it.
Now, just a random, since you called it out, Christian, have you seen The Tao of Steve, the movie?
I have not.
Oh,
no.
I'll send it to you after this. It's one of my favorites. I think it came out in about around in the year in the early 2000s. But yeah,
It's
I'll,
it's a good comedy. Oh man, I'm so in for this. This looks okay. Cool, cool,
I'll
cool.
send it to
I'll
you.
check this out. Yeah.
Yeah, shoot me the link too.
All
I
right,
haven't
all right.
gotten
I think
around
you
that.
guys will both enjoy it. Yeah.
Yeah, absolutely.
I like
Um,
this.
just Christian, you with your background in medical, you pointed out that genome sequencing was using FHE. Is that still the case? I'd love to get your insights, and I'm sure you're like kind of up to date in terms of what's going on in that field.
Yeah,
Do you have
that was
any
in 2000.
insights?
Yeah, that was in 2009. He was a PhD candidate at the time. It was Greg Gentry. I always get Greg Venter and Greg Gentry mixed up because Greg Venter was in a similar place, but I think it was Greg Gentry. So he um he submitted to Stanford that they should use it. They should use homomorphic encryption for sequencing the genome, and they did. And gene sequencing had started some years prior. But the agreement was like, yeah, this is really sensitive data. We don't want this leaked, and we're processing it. We're working on it all the time. This takes many, many months to do. It took, I think, a couple of years. So that
Mm,
was like, okay, it's a lot. That was the first time because it was in 1979 that it was theorized by Adelson, et cetera, and it was built off lattice mathematics, which is advanced form of mathematics. But it's a form of mathematics where you're like plotting points in space, and the space can be multidimensional, can almost be infinite. So it gives you the capacity to like run computation in infinite space. Um, I have about a calculus level understanding of math. So beyond that, I can't, but that's why we have some really, really bright folks on the team who've been developing it. But yeah, the idea is like, look, if we don't have to decrypt data ever, that changes the way we get to interact with the web. That changes policy regulation because if right now all the breaches that happen, as you guys know, but I'll say for the users, like data has three states, right? It's either in storage at rest, it's being sent somewhere, it's in transmission, or it's being processed, computed upon. It's almost always today encrypted at rest and during transmission, but you always have to decrypt it for processing, and that's where a lot of the breaches happen. And so um, we remove a lot of the like a major attack vector from all data everywhere if we can keep it encrypted most of the time, especially during processing. So it's a paradigm shift for sure.
yeah, brilliant. I love hearing you guys, obviously chat about the future and how quickly it's coming on, and obviously the synergy that's unfolding as well.
No,
I
I
think
have
we
I
want
have
to keep.
an additional question here. I know recently we've been hearing a little bit in the news about the 23andMe bankruptcy and sale and how that is going to impact everyone who's done a swab and sent it in. Maybe your data will now have a new owner. Could this have been prevented in some capacity if, potentially utilizing FHE or encryption? Or, I mean, it's probably a business, the decision, but is there a world where, we wouldn't be worried about this? What lessons can we learn, I guess, is my question.
Exactly. Yeah, we've been talking ever since this story came up. This is like the poster child for what goes wrong, with sensitive data in
Sure.
private companies. So Zama actually did this you can go to Zama's website, and I think it was December. They launched an FHE version of 23andMe. So they encrypted the data, and they used the concrete ML SDK so that AI could basically work on the data in its encrypted state. So it's capable. It's you can build it now. The tech is there to build something like that now, depending on how fast you need the insights. But for what 23andMe was doing, it's not like a live your inference is being generated every couple of seconds. It's like it's one report. So you could use FHE to generate that. You could encrypt the data with FHE. You could process it, take as long as you need, run the report, and then the report can be in plain text. But the data that the data that you were processing is in ciphertext. So that's pretty straightforward. They built that, and it's on the website. You can check it. They did like a demo of it. It's possible now. So yeah, in that world with healthcare, if you don't have to worry about the plain text being leaked, then that opens up a whole world of products and innovations and R&D. It would be really fantastic, and personalized care like we can't even
Totally.
imagine. Yeah.
Very cool.
Yeah, there has been some cool stuff that I've just seen in diagnostics and these startups working in that space. So obviously this expedites the possibilities there, which is super super exciting.
Yeah.
But let me jump into some of these community questions, because otherwise I'm going to get hamstrung. So we got one by 0xnkn. This is a good one for both of you guys, which is, what are the biggest myths about ZK and FHE in AI? Are there any technical misconceptions that the community may need to unlearn?
I'll let the big guy go first.
I'll go first. I mean, I think that there is, another one of the reasons that we are working together is, ZK kind of came into prominence because of this idea of privacy and with Zcash and in transaction context. But really, where we're focusing on the AI side is this verifiability piece that we were just talking about: verifiable training, verifiable inference. And there is a lot and scalability, and less so on the privacy and private computation side, which is kind of, I'm assuming what you guys are what you might talk about next. But so really, I think we're leveraging the verifiability and scalability characteristics of ZK more than the privacy characteristics in our applications for AI.
Yeah, I'll piggyback on that. I guess ZK is certainly faster right now than FHE, right? So I don't think this is a misconception that the community has, that FHE is slower and more compute intensive. It's accurate. We can't use it for everything yet. And in many cases, ZK is better and faster to encrypt certain types of data and just put the proof on chain. It's just a better workflow right now for a lot of teams. So I wouldn't say it's a misconception. That's just a common, I guess, grievance you might hear from the community around FHE, and it's partially accurate. Yeah.
Cool. So I think you guys may have touched on this, and we can probably move on if this is right. But when you're talking about the agentic agents with other agents and whether they're encrypted with FHE or not, this question comes from Ethics on Chain, which is, can encrypted agents enforce ethical or regulatory guardrails? If so, how are those rules embedded or audited?
Yeah, that's a great question. So they can work inside of, certainly like in the trading parameters, you could set those guardrails up for sure. What my network's done at the orchestration network, we don't set those guardrails, and so we wouldn't put any of those rules in place. That would, I think, go more to the host of models and the developers themselves at that level. It's a good question.
And I think,
Eric, do you have any insight there?
Yeah, I mean, what I was going to say is, this is something that we've thought about. Like you said, the developers or the model creators are going to have to be the ones that kind of set these guardrails. But you can imagine a world where there is like worldwide standards associated with a model that it must adhere to. You could definitely create ZK proof that just checks those constraints and generates a proof that it passes all of the guardrails. But what those are, I don't think we know yet. But it's definitely something that's possible and could be enforced with like a ZK proof.
Very cool. Thanks for the insights, gentlemen. Again, I'm reading through these, and I think that we have gotten in the weeds with a lot of these, and a lot of these have been answered. So you guys are welcome for the download, and I obviously appreciate it a lot too. There are a couple that of some fun ones though that I'd like to shoot to you guys, which is, so when you first told someone, and let's assume that this is somebody who's not in the field, but when you first told someone about what you're building with encrypted AI networks, did they look at you like you were insane or a genius?
Eyebrow raises, I think, in some cases.
Yeah.
Yeah, Eric. Yeah, I mean, the difficulty we have, that we both have, is ZK proofs and FHE. These are pretty advanced concepts, Do you guys have a hard time explaining these? I mean, I certainly do. We've come up with all these analogies, and we've even used ChatGPT to like give us an analogy that would work for most people. It's like, imagine you have a magician, you put your hand in a box, and we've all these like
Right,
different
right,
things that we
right.
say. So it is hard to kind of get the idea across, and I think the whole like the public versus private data sharing issue has become so big and overwhelming that most people are just like, figure it out. I mean, at this point, it just seems like every company has all of our data, and the big companies haven't really come into Web3 yet. This institutions are coming thing we've been hearing for 7 years hasn't happened, and it's because they can't figure out. They're scared of too much public data. So what's that say for the rest of us that are here messing around? Like, what are we doing? Are we like, are we exposing ourselves all the time in Web3, like like needlessly? So yeah, I think these it's a hard technology to explain. So a lot of times you have people that have a lot of questions or are raising an eyebrow, and then the problem seems so big that it's like, well, how can you prove to me that you're attacking it in an effective way? Because it seems like this big blob that you need to be coming at from a lot of different ways. So
Yeah, I mean, it's definitely incredibly hard. We're very early, right? So there's not a ton of applications of this. What I really think are powerful are when you can share those stories. So like when we're talking about the 23andMe example, and you're like, well, yes, this has been solved. And like that's something that I think people can easily understand, because one, it's like something that happened and is affecting people and they're worried about it in their everyday life. And so they can kind of grasp like why that it's important. We talked about the HTTPS and HTTPZ. Like if you ask someone to explain what HTTPS is doing, like most people probably wouldn't be able to do that, but they're very aware when they go to a site that has a missing certificate and they like get a huge pop-up in their browser, and
Mhm.
they know that it's like good for them, and they know that encrypting their data is generally going to make it safer to interact with websites. And so yeah, I mean, I think it's the more we can start to apply these technologies to tangible applications, it doesn't necessarily need to be like, applications with huge markets, but just ones where we can showcase the technology and people can actually interact with it in a way. And I think is going to make it easier to understand. It is, difficult to go from this kind of theoretical world to this reality. But the quicker we can do that, I think the quicker people are gonna really understand the impact and the potential of these technologies.
agreed.
Yeah, totally.
Yeah.
It's that like abstract to realism kind of thing. And it's funny that Christian, you were saying like, the magician in the box. It makes me think like, whose IP was that originally? Someone probably put that idea into GPT or something, and now we're all getting the same outputs. But maybe that could have been secured, because I spend a lot of time, on the engagement side, and trying to explain to people, like just family members and friends, like exactly what I'm working in. And I'm trying to come up with analogies all the time, whether it's like the foundation of a skyscraper and all these things. And I'm putting them into GPTs. I'm wondering if it's probably going to take some of them. I might have to,
Yeah, the
start
the
encrypting
front
some of them.
running the front running models that just pull the inference from the one with the most powerful amount of compute resources. So you're just getting a
Yeah.
negative or positive feedback loop.
Yeah,
Yeah. Yeah. Copy of a
absolutely.
copy.
Yep, that's it. So Christian, I mean, you mentioned obviously DeFi and AI, and wanting to see, like in the next year, a lot more scaling in this area. Do you have any kind of info on the biggest technical breakthroughs that you're chasing this year, whether it's like protocol level, if it's cryptographic or infrastructure?
That's a good question. That's a good question. I think it's infrastructure, because I think we're going to have to be selective with the types of data that we encrypt for DeFi, and very, very fast. There'll be a lot of stakes, I think, on that, right? Because you're talking about moving billions of dollars in transactions. So
Mhm.
a little bit different than encrypting AI agents. We have encrypted like I think we're above 50,000 agents in Web3 have come registered on our orchestration network. So that's great. But obviously they're not handling the responsibility or the volume of capital that will be happening when we get this like stablecoin policy, for example, the stablecoin regulation, and then you'll finally see money going from JP Morgan coin and Onyx into Avalanche to the tune of like billions of dollars. That's much higher stakes. So I think that's going to be our challenge this year, is if we can get something into those, we'd love to be working with those organizations. If we can get that to happen, that'll be sleepless nights for several weeks.
Yeah, absolutely. And obviously there's so much a synergy between what we're doing. I'm sure there's going to be a lot of applications. Yeah, and again, I'll echo Eric in that I think that we should be having this conversation every quarter, or the way things are moving, maybe even twice a quarter. But great chatting with you, Christian. You did just I want to talk to you offline about this, because you mentioned Star Trek and you're talking about like the laser, and I didn't really catch what that was.
Coherent. I'll
we
send
can
you the link.
probably jump off.
Optalysis
Okay, awesome.
is next level, dude. Coherent. They're doing math in laser light.
Yeah, wow. Okay, yeah. Send me the link. I'll share that with the community as well, because I'm sure there's a bunch of people that would like to know about that. Guys, I've been monitoring the Discord while we've been doing this. We've had a bunch of people loving this show. A lot of love for you guys, and a lot of appreciation for your chat. So just to round things out, we are getting on an hour. Christian, where can everyone find you, man? Where can the builders get in touch? What's the best route?
Yeah, mynetwork_XYZ for all of our socials. And then the website is mynetwork.xyz. And then I'm the DAO of Data on Twitter.
Love that. I love the DAO of Data. That's super cool. Kind of jealous I don't have that handle, to be honest. Very cool. All right, gentlemen. Well, unless you have any other final takeaways you'd like to give us, we might round that out and call it a day.
No, thanks for joining us, Christian. As always, thanks to the community for joining and tuning in. I think we had over 500 viewers today, so that's great, and over 700 questions. So love the interaction. Yeah, Christian, thanks for joining us.
Thank you both. Really, really great time. Thanks to the audience, and we love working with you guys. We're fans of Polyhedra as much as we are business partners. So just happy to be on here with you.
Absolutely. Talk soon.
We're fans of Minds, man. So thank you so much. All right, guys, have a great day, and community, we'll see you next time.
Take care.